Hello, welcome to section 2.1, derivatives and the tangent line problem. Now, we're going to go through a lot of algebra. We're going to work through a lot of algebra this section. We're going to do derivatives. Now, this whole chapter is about derivatives. We're doing it the long way. And then in section 2, it'll get a little easier. So please don't panic when you start seeing this and doing this for yourself. It is a lot of algebra. You're going to have to remember all your algebra tools, all those skills you developed. Just make sure, be patient with yourself to get it done. And know that once we get to chapter 2, section 2, it's going to be a lot easier. So, here we go. Okay, derivative and the tangent line problem. So let's say we have, we've seen this kind of diagram before in section 1.1. So this dashed line is a secant line, and the slope of our secant line is f of c plus delta y. So let's see, what if we call this a c, call this c plus delta x. Here's our delta x. Here's our f of c. Here's our f of c plus delta y. Here's our delta y. So here's f of c plus delta y brings us up there. So the slope of the secant line is f of c plus delta y minus f of c, that's this part here. That's this distance, over c plus delta x minus c. That's where we get our delta y over delta x. The change in y over the change in x. And that's key. We're talking the change in y over the change in x. How it changes vertically over horizontally. And you've seen that before. You've seen that when we did algebra for the first time. You did slope of a line. That's what we're talking about here. And the idea is that we're going to have not the slope of the tangent line, not the secant line, but we'll have the slope of a tangent line, a line that touches in one place. And that's what we're going to be looking at here. Scroll this up a little bit. I want to keep this diagram. So the definition of a tangent line with slope m, if f is defined on an open interval containing c, and if the limit as delta x becomes 0, so here we're talking about the delta x becomes 0, of delta y over delta x equals the limit as delta x becomes 0 of f of c plus delta x minus f of c, so f of c plus delta x minus f of c. But we're talking about as delta x becomes 0, so this point will start coming down to this location. It exists in the line passing through c f of c with slope m is the tangent line to the graph of f at the point c f of c. So the point is as delta x becomes smaller, this point will come down to here and become there, and we have this tangent line going on. So the definition, slope of the graph at f at x equals c, the slope of the tangent line to the graph of f at the point c f of c. That's going to be m. So we want to find the slope now of the graph of f of x equals 3x minus 3 at the point 2, 3. Now, I kind of expect that everyone's looking at this here, f of x equals 3x minus 3. You're saying, hey, Jeff, that is a linear equation. Y equals mx plus b. M is a coefficient for x. Must be 3. Let's see if it works out that way. We're talking about being at the point 2, 3. So the limit as delta x goes to 0 of f of c plus delta x minus f of c over delta x. Now right now if I plugged in 0 for delta x, I'm going to have 0 down here, 0 there, so it's f of c minus f of c, 0 on top. It's a 0 over 0 situation. That's the indeterminate form. We have to work through this. So this is going to be the limit as delta x goes to 0 of, now our c in this case is 2. So c plus delta x is going to be 2 plus delta x. So we're going to have 3 times c plus delta x, that's 2 plus delta x, minus f of c is just our 3. So this is, back it up. This portion here is f of c plus delta x, minus 3, this is f of c, over our delta x. So we have the limit as delta x goes to 0 of 6 plus 3 delta x minus 6. Negative 3 minus 3 is minus 6 over delta x. This is the limit as delta x goes to 0. 6 minus 6 is nothing. We have 3 delta x over 3, and that's just going to be 3's cancel. No, back up. 3 delta x over delta x. That's just going to be delta x cancel. That's 3. Should say the limit as delta x goes to 0 of 3. That's just 3. So our slope, to no surprise, at 2, 3 is 3, as we would expect. That's the coefficient for x. Okay, I'm going to go on to the next page, so feel free to pause this. Example 2. This is find the slope of the tangent line to the graph of the function. So g of x equals 5 minus x squared at 2, 1. Okay, so this is our c, and this is our g of c. Now, this is not as straightforward because this is a quadratic, not linear. So g of 2 is equal to 5 minus 2 squared, which is equal to 5 minus 4, which is 1, and that's what we're getting here. So we're looking at the limit as delta x goes to 0 of g of c plus delta x minus g of c all over delta x. That's the limit as delta x goes to 0 of what? G of c plus delta x. That's g of 2 plus delta x, because our c is 2, minus our g of c, just g of 2, all over delta x. That's going to be the limit as delta x goes to 0. Now, 2 plus delta x is going to go in place of this x in the x squared. So this becomes 5 minus quantity 4 plus 4 delta x plus delta x squared. Minus, and g of 2 is 1. So just remember, I FOILed this out. It's 2 plus delta x squared. That's 4. You can FOIL it, but that's 2 squared plus 2 times delta x plus delta x squared. That's 4 plus 4 delta x plus delta x squared. So what do we have? We have the limit as delta x goes to 0. We have 5 minus 1, that's 4. So 4 minus this 4, minus 4 delta x, minus delta x squared. Now the 4's are going to subtract out. And we have the limit as delta x goes to 0 of negative 4 delta x minus delta x squared over delta x. If we divide out this delta x, we have the limit as delta x goes to 0 of negative 4 minus delta x. And as delta x goes to 0, this just becomes negative 4 minus 0, which is negative 4. So the slope of g of x equals 5 minus x squared at 2, 1 is negative 4. Now the thing about this, being a quadratic, if you go to another point, the slope's going to change. Now, another name for the slope of a tangent line at point C is the, let's everyone say it together, derivative. Let's say it together again. Derivative. Yep, one more time, derivative. It's the derivative. That would be the slope of the tangent line at any given point is the derivative. Now, the derivative has a lot of applications, and we're going to be going through that in this book. That's a big part of our calculus, doing the derivative. And again, we're doing the long form here, the long path to get there. We will learn a shortcut for this, so don't be intimidated with this, overwhelmed. Just trust that this will get almost like second nature to you. So the definition of the derivative of a function is going to be the derivative of f at x is given by f prime of x is the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. A lot of algebra you'll work out in this. Provided the limit exists. For all x for which the limit exists, f prime is a function of x. Now this is f with a little tick mark there. It means f prime of x. It means the derivative. If you have 2, it means double prime, taking the derivative twice. Okay, I'm going to scroll this up. So we just talked about the derivative. Some other terms. Differentiation, that's the process for finding the derivative. It's called differentiation. Different ways to write the derivative, y equals f of x, of y equals f of x would be f prime as we saw, dy dx. Now, I used to get so confused by what's this dy dx. Don't the d's divide out? No, it's not d times y over d times x. It means literally the derivative of y with respect to x. It's just a notation thing. So derivative of y with respect to x is how you'd read that. Y prime with a tick mark there. The derivative with respect to x of f of x. Kind of a long way to write it. It means the same as these others. This one you don't see as often, the derivative with respect to x of y. So often y would be the function, and we're taking the derivative with respect to some variable. Is it x, is it t, is it something else? So dy dx means the derivative of y with respect to x. Now dy dx is the limit as x goes to 0 of delta x over delta y, which is the limit as delta x goes to 0 of f of, this should say, x plus delta x minus f of x over delta x, and that gives us f prime of x. Moving on to example 3. Find the derivative of f of x equals 2x squared plus x minus 1. So this is not going to be at a specific point. This is the general derivative. So we're looking at the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. That's going to be what? I'm going to put x plus delta x in place of this x squared. The limit as delta x goes to 0 of 2 times x plus delta x squared plus x plus delta x minus 1 minus 2x squared plus x minus 1 all over delta x. And that's going to be, I'm going to come down the next line, there's not enough space. The limit as delta x goes to 0 of 2 times x squared plus 2x delta x plus delta x squared plus x plus delta x minus 1 minus 2x squared minus x minus 1 all over delta x. And in this you can start getting rid of some things like this x and this minus x and this, let's just say plus 1. The 1, minus 1, and the plus 1. Distribute here 2 times x squared, it's 2x squared plus 4x delta x plus 2 delta x squared. And we have a plus a delta x minus 2x squared. And in this 2x squared and this minus 2x squared are going to cancel. It's going to give us the limit as delta x goes to 0 of 4x delta x plus 2 delta x squared plus delta x all over delta x. And it's going to work out. If you do this right, you'll only have terms in the numerator with a delta x left in them, and then the delta x will divide out. Four x delta x over delta x is going to be just 4x. 2 delta x squared over delta x is just 2 delta x. And then delta x over delta x is just 1. Now, as delta x goes to 0, our middle term goes away because that becomes a 0. And we're left with 4x plus 1. So the limit, well, I'll just say f prime of x is 4x plus 1. I'm going to go on to the next problem here. Example 4. Find an equation of the tangent line to the graph of f at the indicated point. So here we're going to get the slope, and we have a point. We can use the point slope formula to find the equation of the tangent line. So the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. That's going to be the limit as delta x goes to 0 of x plus delta x squared plus 1 minus x squared plus 1. This is my f of x plus delta x. This is my f of x all over delta x. It's going to be x squared plus 2x delta x plus delta x squared plus 1 minus x squared minus 1 all over delta x. So already you can see some things disappearing. For example, the x squareds and the minus 1 and the plus 1. So we're left with the limit as delta x goes to 0 of 2x delta x plus delta x squared all over delta x. So this is all algebra here. We can divide out our delta x. This is the limit as delta x goes to 0 of 2x delta x divided by delta x is just 2x. Delta x squared over delta x is just delta x. And now as delta x goes to 0, this part becomes 0. So we get 2x. So that f prime of x is 2x. The derivative of f of x equals to x squared plus 1 is 2x. What this means, this function will give us the slope at any point on x. So f prime at 2 is going to be 2 times 2, which is 4. Which means our slope when we're at the point 25 is 4. So we can use a point slope formula, y minus y1 equals m times x minus x1. So y minus 5 equals 4 times x minus 2. Y minus 5 equals 4x minus 8. And we add 5 to both sides. Y equals 4x minus 3. This is the equation of the tangent line So this is the equation of the tangent line at the point 2, 5 for this curve. There's the tangent line's equation. So if you had your parabola, and we're at, it's off a little bit, it's plus 1. So here's 2, and then there's 5. Here's our tangent line. Y equals 4x minus 3. Okay, and that's it. Okay, we go on to the next page, so feel free to pause if you need to pause that. Example 5 says to find the derivative with respect to t for the function y equals 1 over t minus 1. So again, now this has a variable t instead of x, so we're looking at the limit this time as delta t goes to 0 of f of t plus delta t minus f of t over delta t. And the hardest thing about this one is it's dealing with fractions. And a lot of people don't like to deal with fractions. So we have the limit as delta t goes to 0 of 1 over t plus delta t minus 1. So that is to say the t plus delta t went down here, minus 1 over t over our delta t. We need to combine these. Delta t goes to 0 of what? 1 over t plus delta t, not x, Jeff, plus 1 times t over, or t minus 1 over t minus 1. There should be a minus 1 there. Then minus 1 over t minus 1 times t plus delta t minus 1 over t plus delta t minus 1. So we're getting common denominators here. And that's going to be t minus 1 minus the quantity t plus delta t minus 1 all over t plus delta t plus 1 times t minus 1 all over our delta x. So we have t minus 1, distribute here, minus t, minus delta t, minus negative 1 is plus 1. Now notice I did not multiply out the denominator. There's a reason for that. What's left in the numerator? Well, t minus t is nothing. Negative 1 plus 1 is nothing. And we have a negative delta t on top. The limit as delta t goes to 0 of negative delta t over t plus delta t minus 1 times t minus 1 times, this should be a t not an x, times 1 over delta t. This fraction is being divided by delta t, so you can multiply the fraction by 1 over delta t, and the delta t's divide out, leaving you with the limit as delta t goes to 0 of negative 1 over t plus delta t minus 1 times t minus 1. So now if you apply the limit, this delta t goes to 0, only delta t left. You'll have negative 1 over t minus 1 times t minus 1. That's negative 1 over t minus 1 squared. Interesting. It was 1 over t minus 1. Now it's negative 1 over t minus 1 squared. So y prime is going to be negative 1 over t minus 1 squared. Okay, feel free to pause if you need some more time with that one. I'm going to go down the page, down to the next thing. Differentiability and continuity, alternate form of the derivative. Now this alternate form of the derivative will only yield the slope at the point. It's not going to give you the general formula. Okay, so f prime of c, so the derivative at a point c is the limit as x goes to c of f of x minus f of c over x minus c. The derivative exists only if the limit as x goes to c from the left and the right is going to be the same. Example 6, use the alternate form of the derivative to find the derivative of g of x equals x times x minus 1 at c equals 1. So g of x is just x squared minus x. Now what is g of 1 going to be? That's 1 squared minus 1, which is 0. So we look at the limit as x approaches 1 of g of x minus g of 1 over x minus 1. That's going to be x squared minus x minus 0 over x minus 1. Oh, I forgot my limit. Can't forget your limits. The limit as x goes to 1 of g of x, no, I already have that, x squared minus x minus 0 over x minus 1. So this is the limit as x approaches 1 of x squared minus x over x minus 1. And you can factor the numerator. The x minus 1's divide out. Leaves you with the limit as x goes to 1 of x, which is just 1. So g prime at 1 equals 1. Okay, go ahead and pause if you want to. I'm going to go on to the last problem. Use the alternate form of the derivative to find the derivative of g of x equals x plus 3 cubed at c equals 3. So right off, g of negative 3 is going to be negative 3 plus 3 cubed, which is 0 cubed, which is 0. Oh, that's the 1/3 power, not 3. That's 1/3. Right there, 1/3, okay. Okay, let's see here. Looking for the limit as x approaches negative 3 of g of x minus g of 3 over x minus 3. Negative 3. Negative 3. So this is the limit as x approaches negative 3 of x plus 3 to the 1/3 minus 0 over x plus 3, because that's our g of negative 3 right there is at 0. So this is the limit as x approaches negative 3 of x plus 3 to the 1/3 over x plus 3 to the 1. And this would be the limit as x approaches negative 3, x plus 3 to the 1/3 over x plus 3 to the 1. That's going to be x plus 3 to the 1/3 minus 1, which is the limit as x approaches negative 3 of x plus 3 to the negative 2/3, which is the limit as x approaches negative 3 of 1 over x plus 3 to the 2/3. Now if we apply this negative 3 in here, it's going to be 1 over negative 3 plus 3 to the 2/3, which is 1 over 0 to the 2/3, which is undefined. So the derivative does not exist. At x equals -3. Okay, and that'll do it for that part. Theorem 2.1, differentiability implies continuity. If f is differentiable at x equals c, then f is continuous at x equals c. So if you know if it's differentiable, then it is continuous. Well, that'll do it for 2.1. I hope this doesn't frighten you too much. 2.2 is going to be a lot nicer, I predict. So, thank you, and send me your questions. Bye.